So in this video, we will look at solving system of linear equation by using inversion methods. Last video, we looked at how we're going to solve the linear equation by using Cramer rule. So video yang sebelum ni kita belajar menggunakan Cramer rule. In Cramer rule, we are using the determinants of A, or determinants of for x is determinants of A1 divided by determinants of A. Y will be determinants of A2. So I show you. Under the Cramer rule, this is what we learned in the last video. Under the Cramer rule, x or x1 is based on the question is equals to determinants of A1 divided by determinants of A. Second is y or x2 lah, depend on the question, is determinants of A2 divided by determinants of A. And finally is the z or x3 is equals to determinants of A3 divided by determinants of A. This is the previous video. How we're going to find the A1 or A? You can refer back to the video. So in this video, we look at inversion method. So you can see that the words of inversion means that you have to find the inverse matrix. So perkataan kat sini pun ada inversion dah. So maksudnya kita kena cari matrix songsang, inverse matrix. Suppose that we want to solve the equation this one, AX is equals to B. Di mana A adalah matrix tadi yang saya tunjuk tadi tu. X ni variables. B ni adalah the constant lah, ada nilai dia. So if we multiply both sides by the equation of A inverse, so means that in other words, if I move A to the right hand side, it will become A inverse. So X, the variables will be A inverse multiplied by B. So X ni, let's say, if matrix A times X, which is the variables, is equals to B, then the variables X will be equals to A inverse multiplied by B. It's just same like if A, the matrix A move to the left hand side, it will become A inverse. Yeah, A inverse. If the A is located in left hand side, when I move to the right hand side, it also will remain at this left hand side. Dia akan berada di kiri jugalah. Jangan berada kat belakang, kat depan ni. So, what is X? X is our, X ni adalah XYZ kita lah. A inverse ni adalah matrix. This is matrix lah. It's depend lah. Either it's matrix 2 by 2 ke, matrix 3 by 3. And B is the value. We have 3 value here. Or 2 value here. It depend on the question. So means that we have to find the A inverse. A inverse, kita kena cari A inverse lah. A inverse dia ada dua cara. Cara pertama adalah we are using the adjoint method. Yang kita tengok tu. Ada minor semua tu. A inverse kita boleh guna ERO. It depend on you. So you can see that there are two methods to find the inverse matrices, which is adjoint method and ERO, elementary row operation. Like Cramer rule, dia sama juga dengan Cramer rule tadi. First, kita kena represent our equation into the matrix form. Kita tukar dalam bentuk matrix form dulu. AX sama dengan B ni lah. So, let's say, this question 3, 2, 1, 3, 2, and 1, 1, 2, 3, 1, 2, and 3, finally 4, 5, and 7, 4, 5, and 7. Here we have X, Y, Z. And then this is the 5, 8, and 7. So now we are going to use the inversion method. Remember, before the last video, we are using the Cramer rule. So here is our X. This is our A. This is our X, and equals to B. In order to find the X, nak cari X, Y, Z ni. Then this one will become this matrix inverse. A inverse means that through 3, 2, and 1. 1, 2, 3, 4, 5, 7. Inverse multiply by 5, 8, and 7. So don't forget, if by using adjoint method untuk cari inverse, adjoint method, this one is find to find A inverse. So the formula A inverse is equals to 1 over determinants of A multiply by adjoint A. Inilah formula dia. Cari inverse tu. So first, we try to find the determinant dulu. So determinants of A, just like before. Let's say I'm using the first row, plus, minus, plus. So plus 3, close for this one. 2, 3, 5, 7. Sepintas lalu kita dah belajar banyak kali dah. This is minus. Minus 2. So 1, 3, 4, 7. 1, 3, 4, 7. And then plus, here is 1. Close dengan 1, 2, 4, 5. 1, 2, 4, 5. So here I have 3. Here I have 14 minus 15. Oh, sorry. Minus 2. 1 times 7. 7 minus 12. Plus 1. 1 times 5. 5 minus 8. So here is 3. Here is negative 1. Minus 2. Here will become negative 4. Plus 1. Here will become negative 3. So negative 3 plus 8 minus 3. So here is positive 2. Our determinants of A will be positive 2. Yes. So now we want to find the adjoint. Before find the adjoint, first the minor. If you still remember, so you have to remember for this one, minor. Let's say start with M11. Close this one, close this one. This one actually we have found this one. This is the, let's say I show you lah. So 2, dah cari dah sebenarnya. 2, 3, 5, and 7. So this is 14 minus 15 is negative 1. M12. Tutup ini 1, 3, 4, 7. 1, 3, 4, 7. 7 times 1, 7 minus 12. So here is negative 4. And then M13. 1, 2, 4, 7. 1, 2, 4, 5. 1, 2, 4, and 5. So this one we have to be careful. 5 minus 8. Here is negative 3. Proceed to the next one will be M21. Second row, first column. So second row, first column. 2, 1, 5, 7. 2, 1, 5, 7. So this one is 14 minus 5. This will be 9. M22. M22. 3, 1, 4, 7. 3, 1, 4, 7. So this is 21 minus 4. Right? Okay. Here is 17. So M23. You have to do it one by one. Which if we have 9. Close the second row, the third column. 3, 2, 4, 5. 3, 2, 4, and 5. 15 minus 8. So this is 7. Finally, M31. This one, 2, 1, 2, 3. 2, 1, 2, 3. So 6 minus 2 is 4. 6 minus 2, yes. M32. This one, 3, 3, 3, 1, 1, 3. 3, 1, 1, 3. So this is 9 minus 1. So which is 8. Finally, M33, the last one. 3212. 3212. Yes. 3212. So this one will be 6 minus 2, which is equals to 4. So from this minor, before we change to the cofactor matrix, you have to refer to this symbol. Okay. This is positive, negative, positive. Or you can add here. Here is positive, negative, positive, negative, positive, negative, positive, negative, positive. So our cofactor matrix will be equals to positive, negative 1. So here is negative 1. Negative, negative 4 will become positive 4. Positive, negative 3, negative 3. And then finally, 9, negative 9. So negative 9. Positive 17, so it's 17. Negative 7, negative 7. Positive 4 is positive 4. Here's 9. This one is 9. Sorry, I changed to this one. This one is 9. So that you can clearly see that this is negative 9. Negative 8. So here is negative 8. And positive 4. Here is positive 4. And the adjoint, if you still remember, the adjoint A will be the cofactor matrix transpose. So this one is negative 1, 4, and negative 3. Negative 1, 4, and negative 3. Now will become the first column. Negative 9, 17, and negative 7. The second column. Finally, 4, negative 8, and 4. The third column. So therefore, A inverse will be equals to 1 over determinants of A. Sorry. Adjoint A. Where just now our determinants of A will be, which one? Where is our determinants of A? Is 2. Here is 2. Times adjoint A will be negative 1, negative 9, and 4. 4, 17, negative 8. Finally, negative 3, negative 7, and 4. Kamu boleh biar macam ni saja, tak nak expand pun tak apa. Biar macam ni. You want to expand also can. So if I expand, suppose is this one. Our determinants of A is 14 minus 15. Betul 7, 12 minus 4. This one is 5, sorry. 7 minus 12. 7 minus 12, sorry. 7 minus 12. I just found this one is negative 5. Right? Ini negative 5 Sorry. Here is negative 5. Here is negative 5. Sorry, this one negative 5. So this one will become plus 10. Plus 10. So here will be, sorry. So there is 4. Sorry, negative 10, negative 4. Okay, right. So here is positive 5. Will become positive 5. Convert this one will become 5. Sorry, I changed for this one. So here will become 5. So our this one is 4. 1 over 4. Same as this one, negative 1 over 4, negative 9 over 4, negative positive 1, 5 over 4, 17 over 4, negative 8 over 4 is negative 2, negative 3 over 4, negative 7 over 4, and 4 is 1. Okay, right? Yes, correct. So just now, sorry for this one. Here, suppose is some mistake here. Here is negative 7 minus 12 is negative 5, not negative 4. Sorry for this part. This is negative 5. So here is our inverse. You can leave it in this way. Kamu boleh tinggal macam tu saja ataupun you nak kembangkan. Kembangkan jadi macam ni lah. If you like it this way, it's okay can. So then I want to find my value of X, Y, Z. Ingat, tadi kita punya formula adalah A inverse, inverse kita kan? A inverse darab B. A inverse kita is 1/4. Kena tulis balik lah. So our matrix is -1, -9 and 4, 5, 17 and -8, -3, -7 and 4. And then our matrix B, B kita tadi adalah 5, 8 and 7. 5, 8 dan 7. 5, 8 dan 7. So expand. Kita concentrate this one dulu. Yang ni jangan darab lagi. Sebab nanti darab jadi pecahan. Biar macam ni dulu. This one. So macam saya selalu sebut. Biasakan diri buat macam ni. Yes. And then now I multiply. 1/4. First row, first column. -1 times 5. -1 times 5. Plus -9. -9 because negative I put a column, bracket times 8. Plus 4 times 7. Now come to the second column. Baris yang kedua. Baris kedua lah kat sini. Jangan kat belakang. 5 times 5. Plus 17 times 8. Plus -8 times 7. Finally, -3 times 5. Plus -7 times 8. Plus 4 times 7. So from here, 1/4. -5. This one is -72 plus 28. Second row, 25 plus this one 17 times 18. 136. Wait a moment. Okay. 17 times 8. Just now, 17 times 8. Yes, 136. -8 times 7. -56. -3 times 5. -15. This one, -56 plus 28. So, solve for this part. -5 minus 72 plus 28. This one will be -49. The second one, the second row is 25 plus 136 minus 56. This one is 105. And finally, -15 minus 56 plus 28. This one is -43. Is it correct? Let's see. Okay, finally, I just multiply for this part. 1/4 times -49. So it's -49/4. Second one, 105 divided by 4. And the last one, -43 divided by 4. So this is same as this one. So you can see that, therefore, our X will be the first value, which is -49/4. Y will be 105/4. And Z will be -43/4. So this one we known as the inversion method. So this is the inversion method. So what we have to do in inversion method? Of course, you have to find the inverse. So how are we going to find the inverse? We have two methods, which is adjoint method or elementary row operation. So I've shown you is the adjoint method. The example in this book, the same question, but it's using the elementary row operation. So you have two method to compare. So dalam inversion method ni, kita perlu cari, of course, adalah fungsi songsang, inverse function lah. Nak cari inverse function, inverse matrix ni, kita ada dua kaedah. Satu adalah adjoint method, Satu lagi adalah ERO. So, dalam contoh ni, saya guna ERO. Saya guna adjoint method. So, adjoint method cara dia macam ni lah. You kena cari minor dan selebihnya. Cofactor, matrix, and then you have transpose. And we have the formula. Kita ada formula dia. So, dalam buku ni, dia guna ERO. So, you ada dua kaedah lah untuk compare. Jawapan dia sama saja. You can see that. The answer are the same. This one, X is this is the value, Y and Z. They are totally the same. So, beza dia adalah nak guna ERO ke nak guna adjoint method. So, I sum up this topic or this lesson. In order to find the solution for simultaneous for the linear equations, a system of linear equation, we have two methods. One is by using Cramer rule, one is inversion method. So saya buat rumusan untuk kelas hari ini untuk cari linear equation, untuk selesaikan linear equation, nak cari nilai x, y dan z. Kita ada dua kaedah. Kaedah pertama adalah Cramer rule. And most of the time soalan dia akan minta guna Cramer rule lah. And then kaedah kedua adalah inversion method. Dia ada dua cara. Cramer rule, kita menggunakan determinants. Gunakan determinants of A1, A2, A3 bahagi dengan determinants of A untuk cari X, Y dan Z. You boleh rujuk balik video tu. Inversion method pula, kita tengok dia punya topik kita dah. Inversion. Kita kena cari matrix inverse matrix. Kita kena cari matrix songsang. So, nak cari matrix songsang pun ada lagi dua kaedah. Adjoint method dengan ERO. So, adjoint method yang kita kena cari minor lah yang saya tunjuk tadi tu. Cari ERO you boleh rujuk dalam buku ni. Dia guna ERO. Sama saja. So, we have two. One is inversion method. One is Cramer rule. So, you kena ingatlah. So, saya sum up sekali lagi. Cramer rule. X sama dengan, saya guna simbol ni pun boleh, determinants of A1. Yang modulus ni maksudnya determinants. Bagi dengan determinants of A. Y, determinants of A2. Sekali lagi, modulus ni maksudnya determinants. Determinants of A. And then Z, determinants of A3. Bahagi dengan determinants of A. Nak cari A1, A2, A3 dan A, you boleh tengok dalam video sekali lagi. And then we have inversion method. Inversion method, you nak guna adalah, contohnya daripada AX is equals to B. Nak cari X ni adalah A inverse multiply by the B. Apa tu X kat sini? X kat sini bukan X yang satu nilai ni. The X here is represent X, Y and Z. A inverse ni adalah matrix, let's say normally matrix 3 by 3 lah. So contohnya you kena cari inverse dia lah. Contohnya saya guna A, B, C, D, E, F, G, H, I. You kena cari inverse dia lah. Darab dengan A, B, C. Darab dengan B ni. Contohnya B1, B2, B3. So nak cari inverse ni, ini inverse. Nak cari inverse ni pun kita ada dua kaedah. Sama ada you nak guna adjoint method yang saya tunjuk tadi. Adjoint method ada formula dia, you boleh tengok balik. And then satu lagi adalah ERO, elementary row operation. Yang tunjuk kat sini ni, dalam contoh ni ERO. Dan dalam yang saya tunjuk ni, yang saya tulis ni adalah adjoint method. Dalam buku ni adalah ERO. You have two method to find the inverse matrix. Nak cari inverse ni dah ada dua kaedah. So, this one is what we're going to do in this week. Cramer rule by solving simultaneous equation ataupun solving system of linear equation by using Cramer rule or inversion method. So, yang penting personally lah, saya rasa penting yang ni lah. You have to remember this one. Most of the time, question will ask us to use Cramer rule. So, that's all for this lesson. And then hope you enjoy it. And then you have to do the exercise. Thank you.